Mortality data is also estimated through other methods, such as through estimating inter-censal mortality through a technique involving forward projection and cumulation. The method involves overcoming some of the effects of age misreporting that occurs in working with inter-censal estimates. The method is also described in the United Nations manuals with appropriate life tables towards calculation of the overall deaths. Some of the limitations of this model is that it does not overcome effects of misreporting in the initial age distribution on which the method depends.
I am Dr. C.P. Prakasham, retired professor from International Institute for Population Sciences, Mumbai. Module 34, Inter-censal mortality estimated by using forward projection and cumulation. Learning objectives. In this module, you will be learning number 1, estimates reliability, number 2, forward projection, number 3, assumptions, number 4, method of projection, number 5, limitations. Estimates of mortality are associated with 3 different levels of reliability, namely 1. Inter-censal estimates, which relates to a date immediate to 2 census and take the results of these census into account. Number 2. Post-censal estimates, which relates to a past or current data following a census and takes that census and possibly earlier censuses into account but not later censuses. And number 3, projections, which are conditional estimates of population at future dates. Projection. Projection is the computation of future population size and characteristics based on assumptions about future trends in fertility, mortality and migration. Mortality estimated by using forward projection. This method is used to estimate life expectancy at 5. The technique described here for estimating inter-censal mortality is popularly known as forward projection or United Nations Manual number 4 method, which was initially proposed by Cole and Demley in 1967. Assumptions. It is assumed that the population under study is close to migration. Number 2. The inter-censal period n is an integral multiple of 5 years. Number 3. The consecutive censuses are perfectly accurate and the average age schedule of mortality during the inter-censal period is exactly similar to those of a specific model mortality pattern described by a given set of model life tables. The census survival ratio calculated from 2 consecutive censuses as 5pt plus n of x plus n whole divided by 5ptx, where 5ptx denotes the number of persons in the age group x to x plus 5 at time t and n equals to 5 or 10. Here it is assumed that the census survival ratios should be equal to the corresponding life table survival ratios. The survival ratios computed from 2 consecutive census age returns are frequently found high erratic because of age misreporting. To avoid the complexity and subjectivity in smoothing of the age data or raw survival ratios, one may calculate the n-year cumulative census survival ratios, n s0 plus, n s5 plus and so on, which are likely to be quite smooth, where n x plus is defined by n s x plus equals to p t plus n suffix x plus n plus whole divided by pt x plus, where pt x plus and pt n x plus n plus denotes the population aged x and above x plus n and above at time t and t plus n respectively. Translating the cumulative survival ratios into mortality rates, Cole and Deminy proposed forward projection technique with appropriate life table and hence the overall death rate. Method of forward projection. Initially, population at various quinquennial ages starting from age 5 projected forward to second census by applying the survival ratios from a specific model mortality pattern for a range of mortality levels ascertained by life expectancy at birth E0. For each mortality level, projection the population over age x from 10 to 50 obtained by cumulation. Determine the mortality level. Step 1. Projection of initial population and different mortality levels with the inter-censal interval of n years and denoting initial population in the age group x plus 5 by 5p tx. The projected population at time t plus n in the age group x plus 5 denoted by 5pt plus n x plus n, which is obtained by using the life table under level x is given by p estimated population t plus n for x plus n age equals to 5pt x multiplied by the 5 capital Lx k divided by 5 capital Lx for a k value, where 5 capital Lx and 5 capital Lx plus n correspond to a model life table of specified system with level k. Each age group has to be projected using life table with several levels k, and the populations over age x plus n are obtained by cumulation. Number 2. Cumulation of the second age distribution. The second census age distribution is cumulated by summing up populations above certain ages at an interval of 5 years. The number of persons aged x plus 4 according to the first census will reach the age group x plus 5 x plus 9 or x plus 10 x plus 19 on the second census date, corresponding the values n equals to 5 or 10 respectively. Cumulated populations according to the second census date may be taken at age beyond 5 plus n, 10 plus n and so on 45 plus n. Step 3. Projection of initial population with different mortality levels. If the inter-censal interval is 10 years, the probability of surviving between the age group x plus 4 and x plus 10 x plus 14 is approximated by 5 capital Lx plus 10 divided by 5 capital Lx, and such survival ratios can be obtained from a suitable model life table system. The last survival ratio, namely, is that for the population aged 70 and over to 80 and over 10 years later may be approximated as T80 divided by T70. Limitations. Number 1. This method excludes persons aged under 5. Number 2. The relationship between the mortality rate age 5 and that in the age group 5 to 9 as applicable in the model might differ widely than that in the population under study. I will be illustrating with some example. In a research study on learning from indirect estimation of mortality in Mongolia, in the period between 1969 to 1989, the use of projection and cumulation technique is described. It allows for estimation of inter-censal mortality on a general level and requires only the age distribution of two censuses under consideration. One advantage of this method is that age reporting errors are removed through cumulating of the age distribution from the second census. The methods involves projecting earlier census data to the second census, and then projected and enumerated populations are compared under a range of assumptions with the help of life tables. A forward and backward projections give different results. Both can be used to give an average. Example: for Mongolia, forward projection used for census data of 1969 and 1979 for the respective subsequent years, and the West Coal Gemini tables were used to contrast data between forward and backward projections, but the average age distribution is cumulated only for one census, thereby giving different results. It was seen that in the projection and cumulation techniques, the quality of census data, especially between males and females, as also the choice of the life table model, could impact the final estimates of life expectancy. As there is a little data on age-specific mortality for Mongolia, the West model used in the study may not be a suitable fit to the mortality pattern of Mongolia. The choice of mortality model plays a particularly important role in the cumulation and projection techniques, as the survival probabilities of the life tables are used in the projections. However, in conjunction with various techniques, a fuller analysis has been provided.